Hi guys, this is Mrs. Rhodes and I'm going to be doing another lesson on piecewise functions. It's good for you to take notes and for you to write down any questions that you may have so that you can ask your teacher. So the first thing says evaluate the following piecewise function for the values listed. So once again, this is a piecewise function, meaning it's a function that's broken into, this one is broken into three pieces. You can see I have three equations there. So these, if x is less than -1, that's a statement telling me which x's are allowed to go in there. And I'm just going to demonstrate something else as if I had a number line, an x-axis actually. But this is for x's that are less than -1. So -1, an open dot, and going this way, all the x's that are less than -1 are allowed to go into this function. For the middle function here, this is between, if I had my x-axis, it would be between -1 and it's solid because it's equal to that bar underneath the sign there, and then all the way up to 2, and that would be open because there's no equal bar there. And so I'm allowed to put these x's, all the x's between -1 and 2, including -1 but not 2, can go into this equation. And the last equation right here is all the x values that are greater than 2 but not equal to 2. Okay, and so that's going to go that way, and that's allowed to go into this function. So that's what this piecewise function is saying. But now right down here we just have three different values. F of 0. Well, which one is 0? When I'm looking at my picture, 0 is actually right here. So 0 is going to go into the red function. It's in between -1 and 2. So I'm just going to plug then 0, and f of 0 is going to go into 0 squared plus 2. It's going to go into that one. So that's going to be the answer. It's going to be 2. F of 4 is greater than 2. So that's going to go into this function right here. So f of 4 is equal to -1/2 times 4 plus 7. Well, half of 4 is 2. So -1/2 of 4 is -2 plus 7 is 5. And the last one, -1. -1, now this is interesting because -1 is an open dot on the top one, but a solid dot on the second one. That equal bar means -1 belongs to this function. So I've got to plug this into the x squared function. So that's going to be f of -1 is equal to -1 squared. Remember, the negative is getting squared here also. That's the entire point gets squared. I mean the entire x value, because -1 squared is 1 plus 2 is 3. All right, so those are the answers for that. Now it says sketch the graph of the following piecewise function and identify the properties. All right, so once again, we have three different functions here and three different domain restrictions. So let's just take the first one. When we have to graph, I tend to like to make a table, and I'm going to make this one in blue. So this is x, and I just write the equation y equals 1/2, and that's times x squared. And this is for all the x's less than 0. I always start my table at whatever this number is, but I make sure to write a note saying whether it can be open or it should be solid or closed. And the truth is that this should be open because there's no equal bar. So I'm going to write myself a little note to say make this with an open dot. All right, and so 0 goes into 1/2, so this is 1/2 times 0 squared, because I'm just putting the x value right in there, and that's going to be 0. So because this is less than, I've got to go down to -1. So 1/2 times -1 squared. -1 squared is 1, so 1/2 of 1 is just 1/2. And then I'm going to go to -2. 1/2 of -2 squared. -2 squared is going to be 4. 1/2 of 4 is 2. So I'm going to plot these points. So I have 0, 0 as an open dot, and then I have -1, 1/2. So that's going to be right here, and -2, 2, and that's going to be here. So it looks like my graph, and because this goes on forever and ever, goes like this. Okay. Next, we're going to go ahead and I'm going to do this next one in red, the middle one. So I have an x and a y, and this time it's y equals 6. So this is actually only where x is equal to 0. So when x equals 0, the y is equal to 6. So now I have 1, 2, 3, 4, 5, 6 right here. And that's that point. And that's it. That's the red. And let's do the purple. I mean pink. Let's do the last one in pink. So this is x, and this is y equals the square root of x plus 1. So these are for the x is greater than 0. I'm going to put 0 in again. Remember, I told you always put the number that's in the equation. And I'm going to make this an open dot again. And 0, okay, so the square root of 1, so this is going to be 0 plus 1. So that's the square root of 1. So that's going to be just a 1. All right, so the next number that I want to put in, so square root function is interesting because not every number is that great. So for example, if I put in the 1, it would be the square root of 1 plus 1, and that's the square root of 2. The square root of 2 is 1.4, but most people don't know that. So, I mean, I could just keep going. If I put in 2, it's going to be the square root of 3. I don't like that. If I put in 3, though, I'm going to have the square root of 3 plus 1, that's 4. The square root of 4 is 2. So now I know that I have 0, 1, which is an open dot. And then I have 1 is square root of 2. We don't have to put that one. 3, 2. 1, 2, 3, 1, 2. That's a good point. The square root function, as I've always said, kind of looks like an arm reaching out. It's going to be increasing. So that's that part of the function. Okay, one thing to always look at when you have drawn a piecewise function is, does my function pass the vertical line test? Have I not filled in too many dots? And if you had made this dot solid or this blue dot solid, then it would not pass the vertical line test. But right now, this does definitely pass the vertical line test. So this is a function, which is what we want. All right, let's answer these questions, domain and range. Okay, so let's look at the domain. The domain of this picture, of this graph, is actually going to be all real numbers, because even though I have some discontinuities here and I have some jumping around here, this goes from negative infinity all the way up to 0. And even though there's an open dot here at 0, there is a value at 6. So 0 is still included in the domain. And then we're going to keep going to infinity. So my domain is negative infinity to positive infinity. And then my range is an open dot at 0, and then this goes towards infinity. Once again, it doesn't matter that it's broken right here, because I have y values being used all right here in this blue section, and then forever and ever. So basically, this is going to be a parentheses 0, then all the way to infinity. This is not continuous because I have a lot of breaks. All right, so I have a lot of breaks in this function. This has got jump discontinuity, is what we are going to define that in a little bit later. This is bounded below because the range is limited after 0. There's no range values below 0. And there is no symmetry. All right, this is, if we could have folded this at the y-axis and it matched, maybe it would be even symmetry. It would be even symmetry, but that's not the case here. So there's no symmetry. All right, let's go to the next page. This is another piecewise function here, and 3 equations again. So let's just take them one by one. So the first one is going to be y equals x plus 3 for all the x's that are less than or equal to 0. So let me make my table. And I'm going to start at 0, and now I'm going to write solid. And it's a solid dot because of this bar underneath. All right, 0 plus 3 is 3. I'm just plugging it in the x. And this is less than, so this is less. The x is less than 0, so the x's have to be less than 0. So this is going to be a negative 1 plus 3. I'm putting it in for the x. Negative 1 plus 3 is going to be a 2. And basically, you only need 2 points for a line. So this is 0, 3, 1, 2, 3. And then this is negative 1, 2. And so this is going to be my line. Notice the slope is, it's going to be down 1 over 1 in that left side to the left. Or you could go from this point and up 1 over 1. All right, let's do the next line. The next line is y equals, and I'm going to rearrange this. I'm going to move the 3, so it's negative x plus 3. You don't have to do that. You could write it as y equals 3 minus x. There's nothing wrong with that. I like the x first, but actually I'll leave it the way it was. So this is y equals 3 minus x. We'll just leave it like that. Now this is starting at 0 and ending at 1. So this is for 0 and 1. That's it. It's all the x's that are between them, and they both have open dots because there's no bar underneath this. So let me plug in 0. 3 minus 0 is 3, and 3 minus 1 is 2. All right, so I've got to have an open dot here, and then another open dot here, and that's going to be like that. So that's that part of the graph. Now let's do the next one. The next one is y equals x squared, and these are for the x's that are greater than or equal to 1. So now when I plug in x, I'm going to plug in 1. I'm going to make it solid because of that equal bar right here. And this is y equals x squared. So 1 squared is 1. Let's put in 2. 2 squared is 4. This is a parabola. I know the shape. So 1 squared is 1. It's solid. 2 squared is 4. 1, 2, 3, 4. And that's a parabola. I know the shape is going to look like that. All right, good. Make sure. Does it pass the vertical line test? It does because I made an open dot in blue and then a solid dot in red. And actually, that wouldn't matter. It's the same point. But okay, this says f of 1. So what is the y value at 1? There should be only one y value at x equals 1, and it's at 1. So it's in purple. All right, the domain. The domain of this, once again, just like the previous problem, is from negative infinity to positive infinity. It doesn't matter that I have a break right here. If you look at all the x's used, I have x's being used, x's being used. Just because there's a break, a jump discontinuity between this at y is 2 and y is 1 at x equals 1, that doesn't matter. Every x is used. So my domain is negative infinity to positive infinity. All right, let's keep going. Range. The range is, this is going to go on forever and ever. So the range goes from negative infinity all the way up to positive infinity. It doesn't matter that I have these breaks in here. It's just which y values are used, and all the y values are used. And continuous, no, there's a break. There's a jump discontinuity here. And the last one is boundedness, and this is not bounded or unbounded because I have arrows going down and an arrow going up. And then the last one is symmetry. Unfortunately, there's no symmetry. Just go back. How about that? None. All right, I think that's it. Okay, you're going to have some papers that go along with this that we want you to do. We want you to bring your questions tomorrow to class, and have a good day.